Hi everyone, welcome to a new video. In this video, I will show you how to compute the determinant using the Chio's expansion. Chio expansion is a faster way to compute determinant by hand compared to the cofactor expansion. The idea in Chio expansion is that you start with determinant, say 5 by 5, and you're gonna reduce the dimension by 1. So it becomes a 4 by 4 determinant. Then again, you reduce this by 1. It will become 3 by 3. And then again, you reduce this to 2 by 2. 2 by 2 is very easy to compute. So this is the general strategy. Each time you are reducing the dimension by 1. And in every step, the element will be actually a 2 by 2 determinant. So when you are reducing from 5 by 5, this 4 by 4, it will have 4 rows and 4 columns, but each one of these will be actually a small determinant, which is 2 by 2. So this is the first element in this 4 by 4. Then the next element is also 2 by 2 determinant, and so on. So every element of this is 2 by 2. The same thing when you create the 3 by 3. Every element of these will be a 2 by 2 determinant. So this will become very clear through the examples. So let's jump into the details. Let me show you how to do that. We'll first start by doing this process for a 3 by 3 to understand the steps, and then we'll apply it again for a 4 by 4 determinant. So let's take our first example. Our first example is 3 by 3. Okay, so this is our first determinant, a 3 by 3 determinant. So there's a shortcut to compute a 3 by 3 determinant. You can check the video on the channel, but here let's find out this by using the Chio expansion. So to do this, the first thing that you need to do is to select an element, which we call it the pivot element. You can select any element you want as a pivot. The only condition is that it should not be 0. In this case, all the elements are non-zero, so we can pick anyone. So let's select this. This will be our pivot element. And then let's highlight the row and the column for this pivot element. So here we have this. So here the first row and the first column are highlighted because these are the row and columns for the pivot element. What to do next? We will have one factor here, which is 1 divided by the pivot element, whatever the element that you select. In our case, we selected 1. If you selected 5, we're gonna write here 5. And then this will be raised to a power, which is 3. 3, this is the number of rows in the original determinant, minus 2. This minus 2 is always fixed, but this 3 represents the number of rows in the original determinant. Now we'll have a 2 by 2 determinant. So here we'll have a 2 by 2, but each element of this 2 by 2 elements is actually a 2 by 2 determinant itself. How are we gonna find these 2 by 2 determinant? This is the key step. We'll find it as follows. So let's go row by row in the original determinant. So we are looking for the non-highlighted elements. So the first non-highlighted element is 1 here. Now, so we'll have a 2 by 2 determinant. This is the first element. 2 elements of this 2 by 2 determinant will be the non-highlighted element and the pivot. So both of them are 1. What are the other 2? The other 2, you can find them as follows. You can draw a horizontal line from the non-highlighted element toward the highlighted column. And also you draw a vertical line from the non-highlighted element to the highlighted row. So the 3 and 5 will be the 2 other elements. Another way to think of this is that pivot and the non-highlighted element, the 1 and 1 here, are corners of a rectangle. So we need the other 2 corners. So visually, if you think of it, the other 2 elements that will help you to draw a rectangle is the 3 and 5. So your element will be, you read them in the same order. So you'll have 1, 5, 3, and 1. So this gives us the first element in the 2 by 2. The second element also will be a 2 by 2 determinant. And this one also will get it by looking at the second non-highlighted element. The second non-highlighted element is this 2 here. Again, one element will be the non-highlighted element, which is 2, and the other one is the pivot, which is 1. Then The other two, again, we can get them by drawing vertical line toward the highlighted row and horizontal line toward the highlighted column. So this will give you the 3 and 7. Or the other way again to think of it is that the 1 and 2 are corners of a rectangle, and we're looking for the other two numbers that represent the other two corners of the rectangle. So in this case, again, we can write this in the same order: 1, 7, 3, 2. Then we move to the next row. So the first non-highlighted in the next row is 3. Again, this will be one element in the 2 by 2 determinants that will represent the next element in our reduced 2 by 2 determinant. So again, the two elements will be the pivot, the non-highlighted, and then we need 2. Again, you can get them by drawing a vertical line toward the highlighted row and a horizontal line toward the highlighted column. So this will give you 2 and 5. Or again, think of it as 1 and 3 represent two corners of a rectangle, and then you are looking for the other two numbers that complete the rectangle, which would give you 5 and 2. The last non-highlighted element is 4. So this 4 and the pivot 1, here is the pivot, 4 is the non-highlighted element, are two elements of the last determinant. And the other two elements, again, you can get them by visualizing that 1 and 4 are corners of a rectangle, and then you will need the 2 and 7 to complete the rectangle. So this is a 2 by 2, but each element of it is a 2 by 2 determinant. So once you expand this, actually, 1 raised to anything is 1. So this one will be actually 1 times. Now, if we expand the first determinant, 1 times 1 is 1, minus 3 times 5. So this gives you minus 14. Then 2 times 1 is 2, minus 3 times 7, 21. So 2 minus 21 give you minus 19. And then we expand the next one. 1 times 3 is 3, minus 2 times 5, which is 10. So that will give you a minus 7. The last determinant here is 1 times 4, give you 4, minus 2 times 7, that is 14. So 4 minus 14 give you minus 10. So we have this 2 by 2. Now this is easy to expand. Minus 14 times minus 10, that give you 140. Minus 7 times minus 19, that give you 133. So this give you 7. Okay, so that was the general process. Let's now do this expansion for a 4 by 4 example, just to show you how things work with 4 by 4. It's again the same process. So this is our next example. So here we have a 4 by 4. So we're gonna reduce this to 3 by 3, and then we'll take the 3 by 3 and reduce it to 2 by 2, as we did in the previous example. So the first thing is that we need to pick a pivot element. Anything can be picked as long as it is not 0. So in this example, let's say you're gonna pick 8. So now let's highlight the row for this element and the column also for this element. So the remaining non-highlighted element, we're gonna use them to construct the elements of the reduced 3 by 3. So again here, we'll have 1 over, this is a factor, and we write 8. 8 is the element that you pick as a pivot. So here 8, and then the number of rows of the original determines for minus 2. So minus 2 is always fixed. And then here, we are going to create a 3 by 3 determinant. But each element of this 3 by 3 is actually a 2 by 2 determinant. So the first element will be a 2 by 2 determinant. How we get that? Again, you just move systematically through the rows and picking the non-highlighted element. So the first non-highlighted element is 1. So 1 and 8 is the pivot, will be a corner of a rectangle. And so I'm now looking for what are the other two elements that will form the rectangle. So here the two other elements will be the 1 and 3. The other way again to find them is you starting from 1, you draw a vertical line toward the highlighted row and a horizontal line toward the highlighted column. So again, that will lead you to 3 and 1. So again, writing the elements in the same order. So 1, 3, 1, 8. This gives us our first element. Then we move to the next one. The next one is 5. So again, 5 and 8 will be two elements in the determinant. The other two elements, again, you can get them by visualizing a rectangle. Two corners of it is 5 and 8. The other two should be 3 and 6. So here you'll have 5, 3, 6, and 8. Then the next non-highlighted element is 4. Notice that we skip 3 because 3 is highlighted, so we go to 4. And here 4 and 8 are also two corners of a rectangle. And to get the other two, visually you can see what are the two other numbers that will help you to draw a rectangle, which is 3 and 1. All you starting from the 4, you draw a horizontal line toward the highlighted column and a vertical line toward the highlighted row. That again give you 3 and 1. So again, you have to be careful here. You need to write these in the same order. So we'll have 3, then 4, then 8, then 1. Okay, so this gives us the first row in our 3 by 3 determinant. Next, we move to the second row and we'll find here the first non-highlighted element is 2. So 2 and 8 are corners of a rectangle. The other two to complete the rectangle will be 3 and 1. Then we move to the next one, which is 1. Again, 1 and 8 are corners of a rectangle, and the other two to draw the rectangle will need the 3 and 6. So again, you need to write them in the right order. So 1, 3, 6, 8. Then the next one will be this 2. Again, 2 and 8 are corners of a rectangle, and the other two to draw this rectangle, you need 3 and 1. So writing them in the right order, 3, 2, 8, and 1. So this gives us the second row of our 3 by 3 determinant. Now we have only one row left. Notice now the third row here is highlighted, so skip it. Then the next one, the first non-highlighted element here is 3. So 3 and 8 again will be corners of a rectangle. The other two elements that you'll need to draw the rectangle will be 1 and 2 there. So we'll have 1, 8, 3, and 2. Next element, this is 0. So again, 0 and 8 will be corners of a rectangle. The other two elements you need to create the rectangle are 6 and 2. So writing these in the same order will be 6, 8, 0, and 2. Last one is this 2. This is the last non-highlighted element. So again, the 8 and 2 will be two corners of the rectangle. The other two that you will need to create the rectangle are 1 and 2. So you'll get 8, 1, 2, and 2. Okay, so now we have this 3 by 3. We just need to evaluate these smaller determinants. So get here. So 8 to the power 2, that will give you 64. And here, if you expand these, you're gonna get 5, 22, minus 29, 13, minus 10, minus 13, minus 22, 12, 40. So now we have 3 by 3. We can again apply the same method to reduce it 2 by 2. Or you may also want to use the shortcut to evaluate 3 by 3, but let's do it using the Chio expansions. So we have this 1 over 64. Now here again, we need to pick some pivot element. Let's say we're gonna pick this 22 as a pivot. So let's highlight its row. This is its row and this is its column. So then times 1 over 22. This is the element that we select as a pivot. Then here power 3. This is the original size for this determinant. So 3 minus 2, as we said before, minus 2 is always fixed. Then this 3 by 3 will gonna make it 2 by 2. But remember this 2 by 2, each element of it will be a 2 by 2 determinant itself. So again, the first non-highlighted element here is 13. So 13 and 22 are corners of a rectangle. The other two elements you need to complete this rectangle is 5 and minus 10. So again, we write this in the same order. And then the next non-highlighted element is minus 13. We skip the minus 10, it's so highlighted, so we're going to the non-highlighted. So again here, the 22 and minus 13 are corners of a rectangle. The other two create this rectangle is minus 29 and minus 10. So essentially what you'll have is 22 minus 29, and here minus 10 and minus 13. Then the next non-highlighted is minus 22. So 22 and minus 22 are two elements of the rectangle. The other two to draw the rectangle will be 5 and 12. So you have 5, 22, minus 22, and 12. The last non-highlighted element is 14. Again, this 14 and 22 are corners of a rectangle. And the other two to draw this rectangle will be minus 29 and 12. So we'll get 22, minus 29, 12, and 14. Okay, now it's a matter of expanding this. So here 22 actually to power 1, that's just give you 22. If you multiply this out, we're gonna get 1408. And then again, these small 2 by 2 determinant, we can expand them. These are easy to expand. So the first one will give you minus 3, 3, 6. The next one will give you minus 5, 7, 6. The next one will be 5, 4, 4. And then the next one will be 6, 5, 6. Again, expanding this will be 1, 4, 0, 8. If you multiply this, you'll get, and then the other ones will give you 3, 1, 3, 3, 4, 4. And if you calculate all of this, you're gonna get 66. So that's it for this video. If you find this video useful, please give it a like and consider subscribing to the channel and turning the notification on so that you get notified about new content. Thank you for watching.